Okay, today we're doing Module 2, Lesson 25, and today is all about estimating again. It's going to feel very similar to what we did before, except today we're having some decimals. And anytime we divide with decimals, it means we're thinking about place value. It means we're going to rename the number into a different unit. Okay, for example, if we have this decimal, 25 and 2/10, we could rename it as 252 what? Tenths, right? Or we could say it's 2 tens and 52 tenths, right? Or we could say it's 25 ones and 2 tenths. Do you see how there's many different ways to break it up and name it? Every time we deal with decimals, we are thinking about that, okay? Today we're using our estimation skills. We're going to estimate the quotient in order to help us find a reasonable place to put the decimal point, okay? Remember that where we put the decimal point really changes the size of the number, right? If we have this number, 25 and 2/10, does this decimal point right here make a difference?
Yeah.
What if I put the decimal here instead? Did the value of the number change?
Yeah.
Did it get bigger or smaller?
Bigger.
How many times bigger?
10.
10 times bigger. What if I put the decimal point, what if I move it, let's say here? Did it get bigger or smaller?
Smaller.
Yeah. How many times smaller did it get from its original number? 100 times smaller. So where we put the decimal point really affects the size of the number, yes? So by estimating, it helps us make sure that we give the quotient a reasonable size, because wherever we put the decimal point, it changes the size. Yes? Good. The directions tell us to estimate the quotients. So let's write down this first problem, 3.53 divided by 51. Based on what we know about estimating division problems, should we estimate the whole first or the divisor first? Good. What number is the divisor here? 51. So 51 is pretty close to what number? 50. So it's going to be pretty close to something divided by 50. Now, if we're going to divide by 50, that tells us we're thinking about what math facts? Fives. So let's count by fives. 5, 10, 15, 20, 25, 30, 35. Ooh, let's stop at 35, because do you guys see how this is the same as 30? It looks like 35 right there?
Yeah.
Right? But it's 35 what? Tenths. Good. So we can write this as 35 tenths. Now, again, I'm going to point this out to you. It's super important to write that, because if I don't write 35 tenths, what might I do?
You might think they're ones.
Yeah. But let me ask you a question. Is 35 easily divisible by 50? No, because it's too small. So rather than call it 35 tenths, could I call it 350 hundredths? Good. Okay. And again, it's very important to write the word hundredths. Now, what's 350 hundredths divided by 50? Well, let's write it in two steps. We would have 350 hundredths divided by what? 10 divided by 5. Now let's do the first part first. 350 divided by 10, which is what? 35 hundredths divided by 5. Now what's 35 divided by 5? 7. But what's my units? Hundredths. Good. Now if you get to this point, you've done most of the work. But you have to do the last step, which is to write your answer in standard form. So how do I write 7 hundredths? 0.07. Great. Okay, and you could box that to show that that's your final answer. If I were to write 240 tenths in standard form, it would be 24.0, right? Because I would need that 0 to be in the tenths place. Is that pretty close to our original number? 24.2 is pretty close to 24.0. So we know that that is close. Okay, now let's write this out in two steps. So it'd be 240 tenths divided by 10 divided by 4, right? Good. And now again, I know it's an extra step to write out, but writing this out helps you make sure that you divide it correctly. Oftentimes we're making mistakes putting too many zeros or too little zeros, and if we write out this in two steps, you won't make the mistake. And it doesn't take very long. Now we can do 240 tenths divided by 10. What is that? 24 tenths. I want you to notice I'm still writing the word tenths, okay? Divided by 4. Okay, what's 24 divided by 4? 6, and we're in what units? Tenths. Okay, and we have to remember to write it in standard form, so that's 0.6. Looking at these three problems, A, B, and C, do you see how they all have the same digits? But what's different? The decimal point. Look, in the hole here, the decimal point's right there. In the whole here. Where's the decimal point in part B? It's right here, right? You just can't see it because it's in the ones place. And then it's right here too. Does that mean does the decimal point make a difference?
Yes.
What's it doing? It's changing the value of the number. Which number has the biggest hole, A, B, or C? B. Which one has the smallest hole, A, B, or C? A. A is how many times smaller than B? 100 times. And C is how many times smaller than B? 10 times. Because you see how the decimal point has moved, right? Okay, so let's use what we know to estimate the quotient in part A. Okay, first copy down all three problems. So in part A, of course, we're going to round the divisor first. So 42 is pretty close to what number? 40, okay. And 9.13, well, we can think of that as, well, first of all, what math fact should we be thinking about? Fours. Okay, so let's count by fours. 4, 8, 12, 16, 20, 24, 28, keep going. Okay, so are we going to be close to 91 anytime soon? What about 800? Could we do that? We could think of it as, if we're going to think of this as 800, it would be 800 what's? Hundreds, okay. Okay, and how would I write this in two steps? It'd be 800 hundredths divided by what? Divided by 10, and then divided by 4. So let's do 800 hundredths divided by 10 first. What's 800 divided by 10? Everyone? 80, but our units is hundredths, right? So it's 80 hundredths divided by 4. What's 80 divided by 4? 20. And what's our units? Hundredths. Okay, so how do I write 20 hundredths in standard form? 0.2. So it's the same thing as 2 tenths, right? Okay, now let's look at part B. We're not going to actually go through this whole process because we don't need to. How does the whole for part B, 913, compare to the whole in part A? It's the same digits, but is it the same value?
No.
Is part B bigger or smaller? We just said. How many times bigger? So if I start out with something 100 times bigger and I divide it by the same number, 42, will the quotient be bigger or smaller?
Smaller.
If I start with 100 times more stuff and I share it among the same amount of people, will it be the same or bigger or smaller? Bigger, right? If I have $1 and I have to give Jonathan and Martin each half of my dollar, how much would they get? 50 cents. But if now I have 100 times more, how much do I start with? $100, and I have to share it with them. How much do they now each get? $50. Do they get more or less? More. How many times more? 100 times more, because I have 100 times more that I start out with. So I want you to write in your notebook that part B is 100 times more. The whole is 100 times more than what we started out with in part A. So how is that going to affect the quotient? It's going to be 100 times bigger. So I'm going to take 0.2 and multiply it by 100 to get a quotient that's 100 times bigger. What is 0.2 times 100? 20. So therefore, an estimated quotient for part B would be 20. Do you see how that works? Good. Now if we look at, how does C compare to B? 10 times smaller, so 10 times less. So how will the quotient compare to the quotient of part B? It'll be 10 times less, right? So I have to take the quotient for part B, which is 20, and divide it by 10 to get something that's 10 times smaller. What is 20 divided by 10? 2. Okay, so this part is really testing to see if you know how the size of the whole affects the size of the quotient. If I start out with more things and I divide it by the same number of people, will the quotient be bigger or smaller? Bigger, right? If I start out with less things, but I divide it by the same number of people, will the quotient be bigger or smaller? Smaller. What if I start out with the same number of things, but I share it with more people? Will my quotient be bigger or smaller? Smaller. What if I start out with the same number of things, but I share it with less people? Will my quotient be bigger or smaller? So this is different than what we did yesterday. Today our wholes are different, yes? Yesterday our wholes were the same,